In this video series, I want to return to the concept of object-oriented design, but in this case, I want to include a lot of the new things that we've learned involving subclasses. Now let's remind ourselves what's going on in object-oriented design. The idea is that I'm creating a class to represent a type that is not built into Python. Throughout this video series, we're going to be looking at an extended example. The idea is that I'm going to be adding a fraction type to Python. So if we go over here to Atom Editor, you'll notice that I have a class definition for the class fraction. Now you might ask yourself, well, why do we need a fraction type? I mean, yes, okay, now I can get numbers like 1/2 and 1/3, but I could already do that with floats already, right? But remember what the problem was with floats. Floats were not exact. I mean, we had incredible difficulty just comparing two floats to each other. If I wanted exact, I had to do integers. But integers were only whole numbers. If you think about it, a fraction is the best of both worlds. Because it's one integer over another, it's always guaranteed to be exact. But now I can have parts of a number. I can have 1/2, I can have 1/3, I can even have, say, 5/4. Okay, so now we understand why we need a fraction type. Let's talk about how we would design one. As we said in the object-oriented design lesson, we first start off with coming up with our attributes. Well, the attributes for a fraction are just the numerator and the denominator. So we go over here to the class definition. We'll notice, look, I have a numerator and I have a denominator. I'm using data encapsulation. I'm making the actual attributes hidden, and I'm forcing the user to go through the getters and the setters. And one of the nice things about the setters is it allows me to, well, enforce my invariance. So in the case of the numerator, I'm enforcing that it has to be an integer. In the case of the denominator, I'm also enforcing that it has to be an integer, but in addition, I don't want the denominator to be 0. I don't want to have to worry about divide by 0 errors. In fact, I'm going to go even further than that. I'm going to require the denominator be greater than 0. Because look, if I want a negative fraction, I'll just make the numerator negative and it'll all be fine. Okay, so that's the attributes. Let's make some objects. So I'm going to go over here into the interactive shell. I'm going to import the module. Let's go make a fraction. And so I do this by calling the constructor fraction. And let's give, say, the numerator 1 over the denominator 2. And that's 1/2. And indeed, if I use the string function, look at that. It looks nice and pretty with 1 over 2. I'm going to do one more fraction. Let's do 1/3. Let's assign it to Q. If I look at that by converting it to a string, look at that. I have 1 over 3. Okay, great. So I understand the attributes. The next step in class design is to add all of the operations. Well, what operations do we want to have on a fraction? Well, essentially the math operations. I want to be able to add them, and I want to be able to multiply them, and I want to be able to divide them, and I want to be able to subtract them, and man, there are a lot of operations. Okay, right now, just to keep things simple, let's just talk about add and multiply. Now, to add operations to a class, what we do is we have to add methods to the class definition. So let's go scroll down in the class definition. We'll notice that we have an initializer. Oh, look at this. We have the methods for object representation as well. That's how we got the 1 over the 2. And here we go. Here are our methods that support our operations of multiplication and addition. So how do I add two fractions together? I do that with a method call. I take my first fraction p, and I say I want to add to it the fraction q. And look at that. 1/2 plus 1/3 is 5/6. If I want to multiply them, I just use the method mult instead. There we go. And 1/2 times 1/3 is 1/6. Okay, so this is addition and multiplication, and we pretty much get the idea here. If I just want to add more operations, I just add more methods. That makes more sense. So why do I need to have an entire video series about this? Well, okay. Let's suppose I make 4 fractions. 1/2, 1/3, 1/4, and 5/4. And what I want to do is I want to write a mathematical formula like we have off to the side here, where I'm going to add the first 3 fractions together, all inside of parentheses, and then I'm going to multiply that times 5/4. How do I write that in Python? Okay, well, I take P, I'm going to add Q to it. Well, that's an object, so let's go put that inside of parentheses. And then I want to add R to that, and that's an object. I'll put that inside of parentheses. And then all of that, I want to multiply it times S. And indeed, well, that's the correct answer. You'll notice that it's not simplified. It's not in the simplest form. That's because just to keep my class nice and simple for now, we're not going to add any of those features to either add or multiply. So this is correct, and that's not actually what the problem is. The problem is that expression right there. That is horrible. I mean, that's unreadable. There's no way that I can look at that and say that's exactly the same as this mathematical formula off to the side. And by the way, in Java, this is the only way that you can actually do math. Oh, it's horrendous. Trying to do math in Java is horrible. Well, but that implies that maybe I could do something better in Python. What could I do instead of this? Well, let's think about what I actually want to do. What I really want to do is I want to treat fraction like a number. I want to be able to write an expression like, say, P plus Q plus R times S. Now, if I hit return, you're going to say, well, you can't do that because I don't know how to add a fraction with a fraction. But what if Python did? What I'm talking about here is going to lead into the concept of abstraction. The idea behind abstraction is when I design a class, I want to make it simple for the user to use. And the way that I'm going to do that is that I'm going to hide any messy, unimportant details away from the user. I've been joking throughout the semester that I've been lying to you, but it's not true that I've actually been lying to you. It's just that whenever I introduce Python to you, I only tell you about the things that you need to know and not about the things that you don't need to know. And so that's really the concept of abstraction. And this is one of the core principles of computer science. Now, one of the examples of, well, how we would handle abstraction, we've already seen, and that's data encapsulation. And the idea is that we don't actually allow you to access attributes directly. Instead, you have to go through the getters and setters. But it's even more than that, because with data encapsulation, well, I could have attributes that are inside of the class that I've never told you about at all, because I didn't even make getters and setters for them. It's not the case that they're immutable. It's that they're essentially invisible. Maybe it's because I want them behind the scenes because they make a particular method a lot simpler. And that's okay, because you don't actually need to know that they exist. You only need to know about the attributes which are visible, the ones for which I have getters and setters. That's one issue where I'm going to actually use in order to implement abstraction. The other one, at least as far as Python is concerned, is operator overloading. Now, what do I mean by operator overloading? Let's talk about plus. So I can use plus to add two numbers together. I can also use plus to add two strings together. And this is going to do something very different. This is going to glue the two strings together. Plus is an example of an overloaded operator. It means different things in different contexts, and Python is able to figure out which is which. Wouldn't it be great if I could add an additional context to Python? Tell Python, okay, look, you're already using plus for both numbers and strings. Why not just add fractions to the list as well? And the beauty of that is, well, okay, now I can actually write an expression like this instead of having to do the method calls. And this is incredibly important because remember, one of the things that we're trying to do in abstraction is trying to make the class as simple to use as possible and hide unnecessary details from the user. And one of those unnecessary details is having to look up all of these various methods. Is it called mult or is it called multiply? What's going on here? No need to do that. Instead, what you're going to do is you're just going to use the natural operators that you already know already. And what this is going to do is it's going to take a class that at one point looked hacky and looked like it was written by an 1110 student and make it look natural and make it look like something that is actually built into Python. All right, so I said that we're leading into abstraction, but we've already talked about data encapsulation. So the primary focus of this video series, well, is going to be operator overloading. Well, and some other techniques that essentially look like operator overloading. These are going to be incredibly powerful techniques. And when I show you these, this is going to be a lot like that lesson on the Python memory model. I'm going to finally pull back the curtain and show you things that you weren't aware of that you've been doing all semester long. Operator overloading is an incredibly powerful tool, and it exists not just in Python, but in a lot of different languages. It exists in C++, it exists in C#. It just doesn't exist in Java. So for those of you all who go on to 2110, I'm sorry.